Objective 2A, Introduction to Summation Notation. So I'm going to discuss summation notation, or what this fancy term is called sigma. And then I'm also going to go over, in this video, Objective 2B, evaluating a sequence using summation notation. If you remember from the first video you watched in part 3, evaluating a sequence just means find the sum. And so if we're going to find the sum, we're going to reference both of our sum formulas, arithmetic and geometric. Alright, so to begin, summation notation. This handout says mathematicians are lazy, and it's true. They have come up with so many different formulas that help you do computation so much quicker than just by doing it longhand. So instead of saying find the sum of the series denoted by this explicit formula that also exists down here, from the third term to the seventh term, they made up a symbol to deal with it. So the symbol just says that. The symbol sigma, I'm going to write in this box, just means sum. Please write that down. If whenever you see a big looking E thing, it just means sum, or add everything up. That's all it's saying. There are a few pieces of information that are important to know about sigma, though. 3 highlighted here. The first piece, the 7, or whatever number that exists on the top of sigma. That is the upper limit. Meaning we only care about the 7th term. That's the upper limit of the sum that we care about. Down here, the 3, again, this could be different, but n equals 3, that is the lower limit. So in this, all this is telling me to do is find the sum from the 3rd term to the 7th term. And then finally, 3n plus 2 is the explicit formula. This helps me to know which sum formula to use, arithmetic or geometric. Because of this plus right here, this would tell me that this is an arithmetic sequence. So I use the arithmetic sum formula. And that is what sigma is. So the main thing to remember, anytime you see this big looking E thing, you're going to know that it's just telling you to find the sum of the sequence. This is another way to just write the sequence. They want the 3rd through the 7th term, and you can find the 3rd through the 7th term just by inputting 3 into the explicit formula, and that'll give you the 1st or the 3rd term, and so on. That's just for your information for now. We are going to talk about that in another video. So let's move down to Objective 2B then. Actually evaluating the sequence, or doing the math to find the sum of a specific sequence. Now, the first thing to do, the first step, like usually, is decide, is it arithmetic or geometric? So, in order to do that when written in sigma format, or summation format with the sign of sigma, you need to be able to just look at the explicit formula. If there is a plus or a minus, that tells me it's arithmetic. Another clue. There are no variables in the power. N, the variable of n, is in the linear location. If n was in a power, that would also tell me it's geometric, or if there was multiplication. So I've done my first step. I've decided it is arithmetic. Now, the second step. I'm going to write down, and it's important to know or be able to reference this, so please write this down. If it's arithmetic, then this is the formula I use. S of n equals n times ace of 1 plus ace of n all over 2. So, since it's arithmetic, there are 3 pieces of information I need to know. I need to know n, what n equals. I need to know what ace of 1 equals. And I need to know what ace of n equals. Now, in the first part of this, part 3, it gave you n. In this case, n isn't necessarily given to us. So to find n, Find n. You need to take lower limit minus, I'm sorry, not lower limit, upper limit. Upper limit minus lower limit. And then add 1. So in this case, it is 10 minus 7 plus 1 equals 4. All that is saying, n represents the number of terms in this sequence. All that is saying is that there are 4 terms in this sequence. So I have found n. Another way to do that, if it starts at 7, just count. 7, 8, 9, 10 on your fingers. You should have 4 fingers up if you count. So n is 4. I care about 4 terms. Now, the second piece, find a sub 1. To find a sub 1, you've done this before. All you do is input the first term that I care about in this sequence. And that is, the first term that I care about is the 7th term in this sequence. So to find a sub 1, or the first term that I care about in this sequence, I'm going to do a sub 7 equals, and I'm going to put it into my explicit formula. My explicit formula is right here. I'll write explicit formula, or just put EX for short. So instead of n, I'm going to put 7 minus 3. So a sub 7 equals 7 minus 3 is also 4 in this case. So 4. And then finally a sub n. So to find a sub n, I'll write it over here. To find a sub n, I know that n is 4, so that means I have to find a sub 4. Whatever n is, I have to find it, a sub 4. So I put it into my explicit formula. I'll switch to green really quick. So I'm going to put a 4 in for my n. 4 minus 3 equals 1. So a sub n is 1. So now I have all of the pieces that I need for my step 2. Step 2 had a lot of pieces, but step 2 is really just finding all the pieces that go into my sum formula. Now I can go ahead and finish off, and I'll do that over here, my sum formula. S of n equals, n I now know, instead of n here, I'm going to write 4, times my a sub 1, which is 4, plus a sub n, which is 1, all over 2. So S of n equals 4 plus 1 is 5. 5 times 4 is 20. 20 divided by 2 is 10. So the sum, you can do that on your calculator as well. But again, if you're going to do it on your calculator, I would solve the numerator first and then divide it by 2. Same with if it's geometric. I would solve the numerator first, then divide it by the denominator. Do it separately. So the sum of this, my final answer, is 10. Now, there will be problems you encounter that will be much larger sum than just 10. But go ahead and try the next 2 examples on your own and then raise your hand when you are done, and I'll come check.